Welcome to a journey across continents and exploring the most breathtaking natural wonders our planet has to offer. Today, explore 9 amazing destinations that showcase the raw, untouched beauty of Mother Nature. From the dancing celestial curtains of the Arctic Circle to the ancient sandstone corridors carved by wind and time in the American Southwest, from the thundering waterfalls of Iceland to the pristine rainforests of Australia, we are about to embark on an adventure that spans diverse geographies, rich cultures, and fascinating histories. These aren't just beautiful places, they're living testimonies to the incredible forces that have shaped our world over millions of years. Each location we'll visit today tells a unique story of glacial movements that sculpt mountains, of light phenomena that have mystified civilizations for millennia, of ecosystems that have evolved in spectacular isolation, and of geological formations that defy imagination. We'll walk through ice caves that shimmer like sapphire cathedrals, navigate slot canyons where sunlight paints the walls in waves of gold and orange, and stand before glaciers that have witnessed the passage of countless generations. But here's a question I want you to ponder as we begin. What is it about these natural wonders that calls to something deep within the human spirit? Why do we feel compelled to journey thousands of miles just to stand in their presence? Before we get started on this amazing adventure, I encourage you to hit that subscribe button and ring the notification bell so you never miss out on any of our trips. And one more cool thing, you'll find links in the description below to deals on flights and accommodations that will help make these dreams come true. Now, let's get started. Northern Lights, Aurora Borealis. The Aurora Borealis occurs within the Arctic Circle, specifically in what scientists call the auroral oval, a ring-shaped zone around the magnetic poles. The best viewing locations span across northern Scandinavia, including Tromsø and the Lofoten Islands in Norway, Swedish Lapland around Abisko National Park, and Finnish Lapland near Rovaniemi. In North America, prime spots include Yellowknife in Canada's Northwest Territories, Fairbanks in Alaska, and even occasionally the northern reaches of states like Montana and Minnesota during particularly strong solar activity. Iceland, Greenland, and northern Scotland also offer spectacular viewing opportunities. These regions sit between 65 and 72 degrees north latitude, where the magnetic field lines converge and create the perfect conditions for auroral displays. The landscape beneath these light shows is equally dramatic. Vast tundra expanses, snow-covered mountains, frozen lakes that mirror the sky, and boreal forests where the lights weave between ancient pine and spruce trees. The remoteness of these locations means minimal light pollution, offering the darkest skies and the brightest aurora displays. For thousands of years, indigenous peoples of the Arctic have woven the northern lights into their cultural fabric. The Sami people of northern Scandinavia believed the lights were the energies of departed souls, and they cautioned against whistling at them or waving white cloths, fearing it might attract the spirit's attention. The Inuit of North America held diverse beliefs. Some saw the lights as spirits playing ball with a walrus skull, while others believed they were torches held by spirits guiding the recently deceased to the afterlife. Norse mythology attributed the phenomenon to the Bifrost, the burning rainbow bridge connecting Earth to Asgard, home of the gods. Vikings believed the lights were reflections from the shields and armor of the Valkyries, the warrior maidens who chose which soldiers would die in battle and escorted them to Valhalla. In medieval Europe, the rare appearances of aurora in southern latitudes were often interpreted as omens of war, famine, or divine displeasure. The scientific understanding of the Northern Lights began taking shape in the 17th century when French scientist Pierre Gassendi coined the term Aurora Borealis. In 1621, naming it after Aurora, the Roman goddess of dawn, and Boreas, the Greek god of the north wind. However, it wasn't until the space age that we truly understood the mechanism. The aurora is created when charged particles from the sun, carried by solar wind, collide with gases in Earth's atmosphere. These collisions occur at altitudes between 60 and 200 miles, with oxygen producing green and red lights, while nitrogen creates blue and purple hues. The magnetic field funnels these particles toward the poles, creating the distinctive auroral zones. Witnessing the Northern Lights is unlike any other natural phenomenon because it's both unpredictable and ephemeral. The lights can appear for minutes or hours, can be subtle wisps or violent explosions of color, can move slowly or dance rapidly across the entire sky. Modern aurora hunters use apps tracking the KP index, a measure of auroral activity, cloud cover, and solar wind data to maximize their chances, but there's still an element of luck involved, which makes finally seeing them even more rewarding. The best viewing season runs from late September through late March, when nights are longest and darkest. Peak hours are typically between 10 p.m. and 2 a.m., though displays can occur anytime after sunset. The aurora appears in various forms: arcs stretching across the horizon, curtains that seem to hang from the heavens, coronas that explode directly overhead, and diffuse patches that glow softly. During major geomagnetic storms, the lights can move so rapidly they create the illusion of sound, a crackling or whooshing sensation that some witnesses report, though scientists still debate whether this is a true acoustic phenomenon or a psychological response to the visual spectacle. The Northern Lights represent one of Earth's most magical phenomena, a reminder that we live on a planet with a protective magnetic shield, orbiting a star that constantly sends energy our way. From the Sami who revered them as ancestral spirits to modern scientists who understand them as geomagnetic interactions, the aurora has captivated humanity across cultures and centuries. Whether you're standing in Norwegian Lapland, Alaskan wilderness, or Icelandic countryside, Witnessing these celestial ribbons dance across the Arctic sky will humble you, thrill you, and connect you to the cosmic forces that make life on Earth possible. This isn't just sightseeing, it's experiencing one of the universe's most beautiful collisions of physics and wonder. Ito Moyano Glacier, Argentina. Perito Moreno Glacier is located in Los Glaciers National Park in the Santa Cruz province of southwestern Argentina, approximately 50 miles from the town of El Calafate in the Argentine Patagonia. It's part of the Southern Patagonian ice field, the third largest reserve of fresh water on Earth after Antarctica and Greenland. This ice field covers approximately 6,400 square miles and feeds 48 major glaciers on both the Argentine and Chilean sides of the Andes. The glacier itself extends 19 miles in length and covers about 97 square miles, with an average depth of 560 feet. What makes Perito Moreno extraordinary is that it's one of only 3 Patagonian glaciers that isn't retreating. It's in a rare state of equilibrium, meaning the rate at which ice melts and calves at its terminus roughly equals the rate at which new ice forms at higher elevations. The glacier advances about 6 feet per day at its center, pressing against the Magellan Peninsula and periodically creating an ice dam that blocks the waters of Brazo Rico, a southern arm of Lago Argentino. This ice formation is estimated to be over 18,000 years old, formed during the last ice age when massive ice sheets covered much of Patagonia. The intense blue color visible in the ice is the result of extreme compression over thousands of years. As the ice compacts, air bubbles are squeezed out, and the ice absorbs all light wavelengths except blue, which is reflected back to our eyes. The glacier was named after Francisco Moreno, an Argentine explorer and naturalist known as Perito Expert. In the late 19th century, Moreno played a crucial role in defending Argentine interests during border disputes with Chile, and he explored extensively throughout Patagonia, documenting its geography, indigenous peoples, and natural wonders. In 1877, Moreno became one of the first Europeans to explore the region that would eventually become Los Glaciers National Park. As recognition for his contributions, Argentina awarded him a large tract of Patagonian land, which he promptly donated back to the nation to create Argentina's first national parks. Before European exploration, the region was inhabited by the Tehuelche people, nomadic hunter-gatherers who roamed Patagonia for thousands of years. They called the region Chaltl, meaning smoking mountain, referring to the clouds that often crown the nearby Fitzroy Massif. The Tehuelche had an intimate knowledge of the landscape, including the glaciers, though the challenging terrain and extreme climate meant the glacier area itself was rarely frequented. Los Glaciers National Park was established in 1937 and designated a UNESCO World Heritage Site in 1981, recognized for its outstanding natural beauty, ongoing glacial processes, and significant landform features. The park attracts approximately 600,000 visitors annually, with Perito Moreno Glacier being the primary attraction. The area surrounding Perito Moreno supports a unique Patagonian ecosystem. The Magellanic subpolar forest features lenga and nyaya beech trees, colorful flowers like the Magellan fuchsia, and various lichens and mosses. Wildlife includes Andean condors soaring overhead. These massive birds with 10-foot wingspans use the thermal updrafts created by the glacier. You might spot South Andean deer, huemul, Patagonian gray foxes, and various bird species, including black-chested buzzard eagles, austral parakeets, and the distinctive Magellanic woodpecker. Perito Moreno Glacier offers something increasingly rare in our warming world, a living, advancing glacier that you can safely approach and experience in multiple ways. From the network of walkways where you stand in awe of carving events to ice trekking adventures where you walk across ancient ice, from the historical significance of Francisco Moreno's legacy to the potential once-in-a-lifetime experience of witnessing a rupture event, this glacier provides an intimate encounter with glacial forces that have shaped our planet for millions of years. Blue Grotto, Geotta, Capri, Italy. The Blue Grotto, Grotta Azzurra, is a sea cave located on the northwest coast of the island of Capri in the Tyrrhenian Sea, part of Italy's Campania region in the Gulf of Naples. Capri itself sits approximately 3 miles off the Sorrento Peninsula in southern Italy, accessible by ferry or hydrofoil from Naples, Sorrento, or Positano. The island is a limestone outcrop that rises dramatically from the sea, formed over millions of years as layers of sedimentary rock were uplifted by tectonic forces. The Blue Grotto is a karst cave formed by the chemical erosion of limestone by slightly acidic water over millennia. The cave measures approximately 197 feet long and 82 feet wide, with a maximum height of about 45 feet inside. However, the entrance, the only way in or out, is merely 3 feet high and 6 feet wide, and it sits barely above sea level. This peculiar configuration is the result of geological processes. Sea levels have changed multiple times over thousands of years, and the land itself has undergone bradyseismic activity, slow ground movement, which has lowered the coastline and partially submerged what was once a larger opening. But the real magic lies in the cave's lighting. The brilliant blue illumination is created by a remarkable optical phenomenon. Sunlight enters the cave through two sources: the small entrance you enter through, and more significantly, through a larger underwater opening directly beneath the entrance. Light passing through this submerged opening is filtered as it travels through the seawater. The water absorbs red wavelengths while allowing blue light to pass through. This blue light then reflects off the white sandy bottom of the cave and back up through the water, illuminating the entire cavern from below in that characteristic electric blue glow. Meanwhile, the small amount of light entering through the above-water entrance creates subtle white highlights, adding to the ethereal effect. The Blue Grotto's history stretches back to Roman times. Archaeological discoveries have revealed that the cave was known to the ancient Romans and likely served as a private bath and swimming pool for Emperor Tiberius, who ruled from 14 to 37 AD and spent the last decade of his life on Capri. Underwater excavations have uncovered ancient Roman statues, including depictions of sea gods like Poseidon and Triton, which once adorned the cave. A tunnel and passageway system connecting the grotto to the Villa di Dame Cuta, one of Tiberius's 12 villas on the island, has been discovered, suggesting the emperor had private access to this natural wonder. After the fall of the Roman Empire, the cave fell into obscurity and acquired a sinister reputation among local fishermen. Medieval superstitions held that the grotto was haunted by witches, demons, or monsters that lived in its depths. Fishermen avoided the area, believing that anyone who entered would be dragged underwater by malevolent spirits. This folklore persisted for centuries, keeping the cave largely unexplored. The grotto's modern rediscovery occurred in 1826, when German writer and painter August Koppisch, accompanied by his friend Ernst Fries, was guided into the cave by local fisherman Angelo Ferraro. Koppisch's enthusiastic descriptions of the cave's beauty quickly spread throughout European intellectual and artistic circles. The cave became an essential stop on the Grand Tour, the traditional trip through Europe undertaken by wealthy young European men as part of their education. Climate change and rising sea levels pose potential threats to the grotto's future. If sea levels continue to rise, the already narrow entrance could become even more restricted or completely submerged, potentially altering or eliminating public access. Scientists monitor these changes as part of broader Mediterranean coastal studies. The Blue Grotto represents a perfect convergence of geology, optics, history, and human fascination with natural beauty. From its days as Emperor Tiberius's private swimming pool to its centuries as a feared, haunted cave, and finally to its current status as Capri's most famous attraction, the grotto has captured imaginations across 2 millennia. The magical blue illumination, created by nothing more than sunlight, seawater, and limestone, demonstrates how sometimes the simplest natural phenomena can create the most extraordinary effects. It's a reminder that wonder doesn't always require vastness or grandeur. Sometimes it can be found in a small cave, accessed through a 3-foot opening, where light and water create liquid magic. SKFTFELL Ice Cave, Crystal Cave, Iceland. Iceland's ice caves form within the glaciers descending from Vatnajökull, Europe's largest ice cap, which covers approximately 8% of Iceland's landmass, with over 3,000 square feet of ice up to 3,000 feet thick in places. The Skaftafell region, located in southeastern Iceland within Vatnajökull National Park, formerly Skaftafell National Park, before its incorporation into the larger park in 2008, is the primary location for accessible ice cave tour. The area sits roughly 200 miles east of Reykjavik, near the small village of Herfen. These caves form in the outlet glaciers that flow down from Vatnajökull's main ice cap, particularly in glaciers like Esvineyfellsjökull, Follajökull, and other tongues of ice that extend into low elevations. The geographical setting is dramatic. The glaciers are backed by Iceland's highest peak, Vatnajökull, 6,922 feet, and the landscape combines ice, volcanic rock, black sand, and glacial lagoons into a scene that appears almost otherworldly. caves themselves are not permanent structures, but rather ephemeral formations that develop and change constantly. They typically form during summer when glacial meltwater carves channels and cavities beneath and within the glacier. As winter arrives and temperatures drop, the meltwater freezes or stops flowing, leaving behind hollow spaces, the ice caves. Understanding how these caves form illuminates the dynamic nature of glaciers. During summer, meltwater streams form on the glacier's surface and find their way into cracks and crevasses. Water is a powerful carving agent. It flows downward through the ice, following the path of least resistance, melting and enlarging channels as it goes. Some of this water flows along the glacier's base, where it meets the bedrock, carving tunnels at the ice-rock interface. The stunning blue color visible in these caves results from the same phenomenon that makes deep glacial ice blue. Extreme compression over hundreds or thousands of years squeezes out air bubbles, creating dense ice that absorbs all wavelengths of light except blue, which is reflected back. The purer and more compressed the ice, the deeper and more vivid the blue. The black streaks and patterns visible in many caves are volcanic ash layers from historic eruptions. Iceland sits on the mid-Atlantic ridge, and volcanic activity has been frequent throughout the island's history. These ash layers get incorporated into the glacial ice and reveal the glacier's history, with each dark line representing a specific eruption event. Iceland's relationship with glaciers is ancient and complex. The island was settled by Norse Vikings around 870 AD, and glaciers featured prominently in their sagas and folklore. Icelanders viewed glaciers with a mixture of reverence and fear. They provided fresh water and served as landmarks for navigation, but they also advanced and retreated unpredictably, destroying farmland and produced dangerous glacial outburst floods when subglacial volcanic activity melted ice from beneath. The name Skaftafell itself comes from Old Norse, with skaft meaning shaft or handle and fell meaning mountain, likely referring to the area's distinctive mountain formations. For centuries, this region was accessible only to hardy farmers and shepherds who grazed their livestock on the relatively green land between the glaciers and the sea. The area's isolation ended in the mid-20th century when Iceland's ring road was completed and tourism began to develop. Ice cave exploration in Iceland is relatively recent from a tourism perspective. While locals were certainly aware of ice caves historically, organized tourism to these formations began in earnest only in the early 21st century. As global interest in experiential tourism grew and social media amplified awareness of Iceland's dramatic landscapes, ice cave tourism exploded. What was once visited by a handful of adventurous travelers has become one of Iceland's most sought-after experiences, with thousands of visitors annually between November and March. Iceland's glaciers are retreating rapidly due to climate change. Vatnajökull has lost significant mass over recent decades, and outlet glaciers have retreated by hundreds of meters. This creates a sobering paradox. While ice cave tourism booms, the glaciers that create these caves are disappearing. Scientists estimate that if current warming trends continue, many of Iceland's smaller glaciers could disappear within 5,100 years, and even massive ice caps like Vatnajökull will be significantly reduced. Skaftafel's ice caves offer a temporary window into the frozen heart of Europe's largest glacier, an experience that combines natural beauty, scientific fascination, and environmental urgency. The caves exist at the intersection of fire and ice, formed in glaciers that cap active volcanoes, carved by summer meltwater, and accessible only in winter's cold stability. Standing inside these ephemeral blue cathedrals, knowing they may not exist in the same form next year or may not exist at all in coming decades, creates a poignant appreciation for the dynamic, ever-changing nature of our planet and the precious, fleeting nature of such natural wonders. Antelope Canyon, Arizona, USA. Antelope Canyon is located near Page, Arizona, in the southwestern United States, on Navajo Nation land east of Page near Lake Powell. The canyon actually consists of two separate sections: Upper Antelope Canyon, called Say-Biganalini, or the place where water runs through rocks in Navajo, and Lower Antelope Canyon, called Hastistwazi, or Spiral Rock Arches in Navajo, both formed in the same Navajo sandstone formation, but with distinct characteristics. Upper Antelope Canyon is the more famous and accessible section. At ground level, it's relatively easy to walk through. The canyon floor is mostly flat sand, and the path winds through narrow corridors where the walls tower 120 feet overhead. The canyon is about 660 feet long, and in places, the passage narrows to just a few feet wide, while remaining walkable without climbing. This accessibility and the famous light beams make it the most visited section. Lower Antelope Canyon requires more adventurous navigation. Visitors descend into the canyon via metal staircases and must navigate uneven surfaces, sometimes climbing through narrow passages and occasionally using ladders. It's longer than Upper Canyon at about 1,100 feet and extends deeper underground. While it sees fewer visitors and has less dramatic light beams, Many photographers prefer it for the more varied rock formations and colors. The geological story of these canyons spans millions of years. The Navajo sandstone was formed approximately 190 million years ago during the Jurassic period from massive sand dunes in a desert environment. Over time, these dunes were buried, compressed, and cemented into sandstone. The distinctive red-orange color comes from iron oxide, rust, coating the sand grains. The slot canyons themselves were carved much more recently, in geological terms, by flash flooding over thousands of years. The region experiences monsoon storms during summer months, and when intense rainfall occurs upstream in the watershed, water funnels into narrow channels, creating powerful flash floods that surge through the canyons with incredible force. These floods carry sand, gravel, and debris that act as abrasive agents, scouring and polishing the sandstone walls. The unique flowing, curved shapes result from the water's turbulent motion, flowing in spirals and eddies rather than straight lines, carving organic curves and wave-like formations into the rock. Antelope Canyon holds deep spiritual significance for the Navajo people Diné, who have inhabited this region for centuries. The Navajo view the canyon as a sacred place, a spiritual sanctuary where earth and sky meet, where light enters the earth, and where ancestors' presence can be felt. Traditional Navajo beliefs hold that natural formations like slot canyons are not merely geological features, but living entities deserving of respect. The name Antelope Canyon comes from the herds of pronghorn antelope that once roamed the area, particularly near the canyon entrance. For the Navajo, the antelope is significant both practically as a traditional food source and culturally featured in creation stories and ceremonial practices. The famous light beams that have made Antelope Canyon iconic occur only under specific conditions, creating a pilgrimage-like atmosphere among photographers seeking to capture them. These beams are created when direct sunlight enters through the narrow openings at the top of the canyon and becomes visible as it illuminates dust particles in the air. Essentially, you're seeing the path of light itself. The beams occur primarily in Upper Antelope Canyon during specific times of year and day. Peak season for light beams is late March through early October, when the sun is high enough in the sky to shine directly down into the canyon. The best time of day is between 11 a.m. and 1:30 p.m. when the sun is most directly overhead. During summer months, June-August, the beams are most dramatic and last longest, sometimes appearing as multiple beams simultaneously in different sections of the canyon. The walls themselves create extraordinary color variations. The Navajo sandstone contains different mineral layers that produce varying hues. Iron oxide creates reds and oranges, manganese oxide produces purples and deep reds, while lighter sections appear in shades of pink, coral, and yellow. As light filters through the narrow opening and bounces off these multicolored walls, it creates a kaleidoscope effect, with different sections of the canyon glowing in different colors simultaneously. Antelope Canyon represents the intersection of geological processes, indigenous culture, photographic obsession, and tourism management challenges. From the millions of years required to create the Navajo sandstone to the flash floods that carved these flowing passages over millennia, from the spiritual significance it holds for the Navajo people to the light beams that have made it one of Earth's most photographed places, from the 1997 tragedy that reminds us of nature's power to the current challenges of balancing access with preservation, Antelope Canyon embodies both natural wonder and human relationship with landscape. Komodo National Park, Indonesia. Komodo National Park is located in the Lesser Sunda Islands of Indonesia, situated between the provinces of East Nusa Tenggara and West Nusa Tenggara. The park consists of three major islands, Komodo, Rinca, and Padar, along with numerous smaller islands and surrounding marine areas, totaling approximately 669 square miles, including marine area. The park lies in the Wallacea region, a biogeographical zone between the Asian and Australian continental shelves, named after naturalist Alfred Russel Wallace, who identified the distinct boundary between Asian and Australian fauna. The park is accessible via the town of Labuan Bajo on Flores Island, which has an airport serving flights from Bali and other Indonesian cities. From Labuan Bajo, you'll travel by boat, ranging from simple speedboats to luxurious liveaboard diving vessels, for approximately 2–4 hours, depending on your destination within the park. The landscape is dramatically different from most people's image of tropical Indonesia. Instead of dense jungle, much of Komodo and Rinca consists of dry savanna grassland that turns golden during the dry season, with scattered lonta palms, acacia trees, and rugged volcanic hills. This arid environment results from being in the rain shadow of Flores Island. The monsoons drop their moisture on Flores's mountains before reaching Komodo. However, the islands also have pockets of rainforest in higher elevations and mangrove forests along the coasts, creating habitat diversity. Padar Island offers some of the park's most photographed landscapes. A viewpoint reached after a challenging hike reveals multiple bays with beaches of different colors: white sand, black volcanic sand, and even pink sand, created by red coral fragments mixing with white sand, all surrounded by turquoise waters and dramatic curved peninsulas. The Komodo dragon, Varanus komodoensis, is the world's largest living lizard species, with males reaching up to 10 feet in length and weighing up to 200 pounds. These remarkable reptiles are found naturally on only 4 Indonesian islands: Komodo, Rinca, Gili Motang, and Flores. They are the last surviving members of a group of large monitor lizards that once ranged across Indonesia and Australia. Scientists believe Komodo dragons evolved in Australia approximately 4 million years ago and migrated to the Indonesian islands when sea levels were lower, creating land bridges. When sea levels rose, they became isolated on these islands, where they evolved as apex predators in the absence of large mammalian carnivores. This is an example of island gigantism, the evolutionary tendency for species on islands without predators to grow larger than their mainland relatives. For decades, scientists believed Komodo dragons killed prey primarily through bacterial infection. Their saliva contained so many pathogenic bacteria that a bite would cause sepsis, and the dragon would simply track the dying animal for days. However, research published in 2009 revolutionized our understanding. Komodo dragons actually have venom glands in their lower jaws that produce anticoagulants, preventing blood clotting and inducing shock in prey. The bacteria theory was actually observing the effects of venom, combined with bacteria from their scavenging lifestyle. Komodo dragons are remarkably intelligent for reptiles. They can recognize individual humans, have been observed engaging in play behavior, and demonstrate problem-solving abilities. Their hunting strategy combines ambush tactics with endurance. They can remain motionless for hours waiting for prey, then chase it at speeds up to 12 miles per hour in short bursts. Their diet includes deer, wild boar, water buffalo, and even other Komodo dragons. They're cannibalistic, particularly toward juveniles, which is why young dragons spend their first years in trees. The Western world's official discovery occurred in 1910, when Dutch colonial administrator Lieutenant Jacques Kale Henry van Steen van Hensbroek traveled to Komodo after hearing persistent rumors of large land crocodiles. Local guides led him to the creatures, and he shot 2 specimens, sending them to botanist Peter Ouwens at the Zoological Museum in Bogor, Java. Ouwens published a scientific description in 1912, officially introducing Varanus komodoensis to Western science. The discovery captivated global imagination. Expeditions were mounted, including a 1926 expedition by American adventurer W. Douglas Burden, sponsored by the American Museum of Natural History. Burden's expedition collected specimens for study and museum displays, and his adventures allegedly inspired the 1933 film King Kong, the idea of an expedition to a remote island to capture a giant prehistoric creature. However, early expeditions were harmful. Collectors killed dozens of dragons, and trophy hunters traveled to the islands specifically to shoot them. By the 1960s, concerns about the species' survival led to protection efforts. Komodo Island was designated a nature reserve in 1980, expanded to include surrounding islands and marine areas, and declared a national park in 1980. UNESCO designated it a World Heritage Site in 1991, recognizing both the unique terrestrial fauna and the extraordinary marine biodiversity. Komodo National Park offers a combination found nowhere else on Earth. The chance to walk among real-life dragons, prehistoric predators that survived millions of years on remote volcanic islands, while also diving in some of the world's richest marine environments. From the evolutionary marvel of the Komodo dragon with its venom and parthenogenic reproduction, to the cultural history of a creature dismissed as legend until the 20th century, from the savanna landscapes dramatically different from typical Indonesian rainforest to the pink sand beaches and manta ray cleaning stations underwater. This park showcases biodiversity created by geographical isolation and oceanic convergence. GULLFOSS, Golden FALLS, Iceland. Gullfoss is located in the canyon of the Hvatar River in southwest Iceland, approximately 65 miles northeast of Reykjavik in the Haukadalur Valley area. The waterfall is part of Iceland's famous Golden Circle tourist route, which also includes Thingvellir National Park and the Geysir geothermal area, making it one of the most visited natural attractions in Iceland, with over 1 million visitors annually. The Eyjafjallajökull River originates from Langjekut, Iceland's second-largest glacier, flowing approximately 25 miles before reaching Gullfoss. The river carries glacial meltwater laden with fine sediments. This glacial flow gives the water its distinctive milky white-gray color, though the name Eyjafjallajökull means white river in Icelandic. The waterfall itself consists of two distinct drops. The upper cascade falls about 36 feet, followed by a second drop of approximately 69 feet, for a total height of 105 feet. The water plunges into a narrow canyon that extends over 230 feet deep and continues downstream for more than a mile. The waterfall's formation relates to Iceland's volcanic and glacial history. During the last ice age, catastrophic glacial floods called jökullaups carved out the canyon. These floods occur when volcanic activity beneath glaciers rapidly melts enormous volumes of ice, releasing water under immense pressure that can carve through bedrock. The stair-step formation of Gullfoss's two-tiered drop was created by differential erosion of various lava layers. Harder basalt layers create the step edges, while softer layers eroded away to create the plunge pools. The average water flow is approximately 4,900 cubic feet per second, but this varies dramatically with seasons and glacial melting. During summer glacial melt or following heavy rain, flow can exceed 44,000 cubic feet per second, making the waterfall a truly spectacular and dangerous sight. The sheer volume of water creates a constant thundering sound audible from hundreds of meters away, and generates so much spray that on sunny days, multiple rainbows often arch across the canyon. Gullfoss translates to Golden Falls, but the origin of this name is debated. Some claim it refers to the golden hue the glacial water takes on when lit by the setting sun, as the suspended sediments reflect warm light. Others suggest it comes from the rainbow that frequently appears in the waterfall's mist, which historical observers might have described as golden. A third theory relates to a local legend that a wealthy man, not trusting anyone, threw all his gold into the waterfall before dying, giving it a permanent association with gold. Regardless of the name's origin, the visual effects at Gullfoss are extraordinary. On sunny days, the spray creates vivid rainbows, often double or even triple rainbows that arch across the canyon. In winter, the spray freezes into massive ice formations on the canyon walls and surrounding rocks, creating surreal ice sculptures. The mist also creates phenomenon called ice flowers, delicate frost formations on nearby vegetation. In summer's midnight sun, the waterfall never falls into complete darkness, creating photographic opportunities around the clock. Some visitors time their arrival for sunrise or sunset, when the low-angle light creates the most dramatic colors. Accessing Gullfoss is straightforward. Paved parking areas lead to well-maintained paths and viewing platforms at various levels, offering different perspectives of the falls. The lower path brings you closest to the waterfall, where the spray is substantial, waterproof clothing recommended, and the power is visceral. Standing here, you feel the ground vibrate, the noise is overwhelming, and the scale of water pouring past is humbling. Upper viewpoints provide panoramic perspectives showing both cascade stages and the canyon's full extent. The experience varies dramatically by season. Summer, June-August, offers maximum water flow from glacial melt, the most dramatic volume pouring over the falls, and the best conditions for seeing rainbows. The area is green, and hiking is easy, though crowds are at their peak. Winter, November-March, transforms Gullfoss into an ice wonderland. While water flow decreases, the spray creates stunning ice formations, and the surrounding landscape is snow-covered. Gullfoss embodies the intersection of geological power, cultural history, and conservation values. From the massive volumes of glacial meltwater plunging in two dramatic stages into a canyon carved by catastrophic floods, to the golden hues and rainbows that give the falls their name, to the inspiring story of Sigríður Tómasdóttir, whose determination saved this natural wonder from industrial development. Gullfoss represents both Iceland's raw natural power and the importance of individual action in environmental protection. DAINTREE Rainforest, Australia. The Daintree Rainforest is located in far north Queensland, Australia, approximately 62 miles north of Cairns and covering roughly 463 square miles. The forest extends from the Daintree River in the south to the Bloomfield River in the north, and from the coastal lowlands to the mountains of the Great Dividing Range. What makes this location particularly special is that it's one of the few places on Earth where two UNESCO World Heritage Sites meet. The Daintree Rainforest, part of the wet tropics of Queensland, literally touches the Great Barrier Reef, creating a unique convergence of terrestrial and marine ecosystems. The region's geography is diverse, ranging from sea-level mangrove swamps to mountain peaks over 5,000 feet high. The Daintree River divides the forest into two sections, the more accessible southern section between the Daintree and Mossman Rivers, and the more remote northern section between the Daintree and Bloomfield Rivers. Cape Tribulation, where two World Heritage areas meet, has become an iconic location where pristine beaches, coral reefs, and ancient rainforest converge within a few hundred meters. The climate is tropical, with two distinct seasons. The wet season from November to April brings heavy monsoon rains, sometimes over 200 inches annually in some areas, while the dry season from May to October offers more comfortable conditions for visitors. This high rainfall, combined with poor soil drainage and the region's topographical variety, has created countless microhabitats supporting extraordinary biodiversity. The Daintree rainforest is estimated to be 180 million years old, making it not just old, but the oldest continuously surviving rainforest ecosystem on the planet. To put this in perspective, it predates the Amazon by approximately 125 million years. This forest was already ancient when dinosaurs walked the Earth, and remarkably, it has survived continental drift, climate changes, ice ages, and mass extinction events that eliminated countless other ecosystems. This antiquity makes the Daintree a living library of evolutionary history. The forest contains primitive flowering plant families that provide direct links to the ancient supercontinent Gondwana, which included Australia, Antarctica, South America, Africa, Madagascar, and India before they separated. Scientists study plants here like the Idiospermum australiense, a primitive flowering plant so ancient it's considered a living fossil, found nowhere else on Earth. There are over 390 rare or threatened plant species in the wet tropics, many of which grow only in the Daintree region. The forest is home to 30% of Australia's frog species, 65% of its butterfly and bat species, and 18% of its bird species, compressed into less than 0.2% of Australia's land area. This includes 13 species found nowhere else on Earth. The cassowary, a massive flightless bird that looks remarkably prehistoric, because it essentially is. It has changed little over millions of years, plays a crucial role as the forest's gardener, dispersing seeds from fruit too large for any other animal to swallow. The Daintree region is the traditional homeland of the Eastern Kuku-Yalanji people, who have lived in continuous connection with this landscape for over 50,000 years, making their culture one of the world's oldest continuous cultures. The Kuku-Yalanji name for the forest is Daintree, comes from European explorer Richard Daintree, who surveyed the area in the 1870s, but the indigenous peoples knew it by many names related to specific areas within their country. European colonization devastated indigenous communities through disease, displacement, and active persecution. The Kuku-Yalanji were forcibly removed from much of their traditional lands, and many cultural practices were suppressed. However, the community has persevered, and in recent decades, there's been a resurgence of cultural pride and recognition. Indigenous-owned and operated tourism ventures now offer visitors authentic experiences, walking through the forest with Kuku-Yalanji guides who share traditional knowledge, plant uses, creation stories, and perspectives on caring for country. The Daintree rainforest is not just a beautiful destination. It's a biological time capsule, a living connection to Earth's deep past, and a functioning ecosystem of staggering complexity. From the Kuku-Yalanji people who have sustained their cultural connection here for 50,000 years, to the primitive flowering plants that link us to Gondwana, from the prehistoric cassowaries that maintain forest health, to the modern conservation efforts buying back land piece by piece, the Daintree tells stories of survival, adaptation, and the ongoing negotiation between human needs and environmental preservation. The Wave, Coyote Butts North, Arizona, USA. The Wave is located in the Coyote Buttes North area of the Paria Canyon-Vermilion Cliffs Wilderness, which straddles the border between Arizona and Utah in the United States. The formation sits on the Colorado Plateau, approximately 42 miles south of Kanab, Utah, and about 20 miles from the small town of Marble Canyon, Arizona. This remote location requires substantial effort to reach. There are no paved roads to the trailhead, no marked trails to the formation, and no facilities of any kind. What makes the Wave truly unique is its extreme access restriction. The Bureau of Land Management, BLM, which manages this federal wilderness area, limits visitation to just 20 people per day, 10 permits distributed via advance online lottery, held 4 months before the desired hiking date, and 10 via walk-in lottery, held the day before, at the Grand Staircase Escalante National Monument Visitor Center in Kanab. These restrictions exist to protect the fragile sandstone formation from erosion while preserving the wilderness experience. The demand is extraordinary. The online lottery typically receives over 150,000 applications per year for roughly 3,650 available advance permits. Odds of winning are approximately 2–5% depending on the season. The walk-in lottery offers better odds, around 10–20%, but requires traveling to Kanab without knowing if you'll get a permit. Some dedicated visitors apply month after month, year after year before finally winning. The wave formed during the Jurassic period, approximately 190 million years ago, when the region was covered by a vast desert, a landscape of massive sand dunes comparable to today's Sahara Desert, but located near the equator before continental drift moved North America northward. These ancient dunes were hundreds of feet tall, constantly shifting with prevailing winds. As sand accumulated in layer after layer, the weight of overlying sand compressed the lower layers, and mineral-rich groundwater cemented the sand grains together through a process called lithification, creating sandstone. The distinctive undulating patterns visible today in the wave represent crossbedding, the internal layering structure of ancient sand dunes. When wind blows across a dune, sand grains accumulate on the downwind side in sloped layers. As the dune migrates, new layers are deposited at different angles, creating the crisscrossing pattern now exposed in the rock. The wave's dramatic curves represent the preserved lee slopes, downwind sides of those ancient dunes, frozen in stone. The varying colors, red, orange, yellow, white, and pink bands, result from different iron oxide concentrations and chemical conditions during formation. Red layers contain hematite, oxidized iron, orange and yellow layers have goethite, hydrated iron oxide, while lighter bands have minimal iron content. Groundwater movement after lithification also played a role, with mineral solutions creating some of the color variations and intricate patterns as they percolated through the rock. The exposed surface we see today was revealed through differential erosion. Water, wind, and weathering removed overlying rock layers and continue to slowly erode the surface, gradually revealing the internal structure of the ancient dunes. The smooth, flowing appearance results from water erosion. Even in this desert environment, occasional rainfall creates runoff that polishes the sandstone surface, accentuating the swirling patterns. The wave sits within the Navajo Sandstone Formation, one of the most extensive Aeolian wind-deposited formations in the world, covering over 400,000 square miles across the southwestern United States. This formation contains some of the world's best-preserved records of ancient desert environments, providing scientists with insights into Jurassic climate patterns, desert ecosystem dynamics, and geological processes. European American exploration of this specific area came relatively late due to its remoteness and harsh desert conditions. Early Mormon pioneers and ranchers knew the region in the 19th century, but the wave remained relatively unknown outside local circles until the late 20th century. The formation gained wider attention in the 1990s as southwestern adventure tourism expanded and guidebooks began featuring it. Its appearance in advertisements, films, and increasingly on social media has made it one of the most desired destinations in the American Southwest. Reaching the wave requires a strenuous 6-mile round-trip hike through trackless desert terrain with no marked trail, significant elevation changes, and exposure to harsh desert conditions. The hike typically takes 4-6 hours depending on pace and time spent at the formation. Permit winners receive maps, GPS coordinates, and photos of key landmarks, but navigation remains challenging. Many hikers get lost or disoriented despite these aids. The route crosses sandy washes, traverses slick rock, smooth sandstone surfaces, and navigates between sandstone formations where landmarks can look confusingly similar. Cell phone service is non-existent. Summer temperatures regularly exceed 100 degrees F with no shade, creating dangerous heat exposure. Winter brings freezing temperatures and potential snow. Flash flood danger exists during monsoon season, July-September, and any time thunderstorms threaten. The wave represents geological artistry at its finest. 190 million years of wind, water, and chemical processes have created patterns and forms of such perfection they seem designed rather than natural. From the Jurassic dunes that accumulated in layer after layer, to the lithification that turned sand to stone, to the erosion that revealed the internal structure. From the iron oxides that painted bands of color, to the polish of water that smoothed the surfaces to flowing perfection, every aspect of the wave's formation contributes to its extraordinary appearance. So here we are, at the end of our journey through 9 of Earth's most extraordinary natural wonders. We've danced with the aurora in Arctic skis, witnessed glaciers carving new landscapes, entered blue grottos and crystal caves that glow like jewels, walked through rainforests older than our species, met modern dragons on volcanic islands, felt the power of golden falls, and traced the flowing lines of stone waves in the desert. But what does it all mean? What can we take from these wonders beyond beautiful photographs and memories? Nature isn't just something to see, it's something to feel, to respect, and to protect. Every single one of these wonders exists because of time, patience, and the right conditions converging over millennia. Many are fragile, some are disappearing. The ice caves are shrinking, the glaciers retreating, the ecosystems under pressure. Our generation has a choice. We can be the people who visited these wonders, or we can be the people who ensured they survive for future generations. Now let me ask you one final question. Which of these 9 wonders spoke to your soul? Which one made your heart race just hearing about it? Drop your answer in the comments below. If you found value in this journey we've taken together, please subscribe to the channel and hit that notification bell so you don't miss future adventures. I'm constantly exploring new destinations and sharing the stories, practical advice, and inspiration you need to become a confident world traveler. Share this video with anyone who loves nature, beauty, or adventure. Let's spread the wonder together. Until next time.